Okay, so we started this lesson with a big bag of beads, and each group got 20 beads randomly out of the bag and found the proportion of red beads in the bag. So for our example, let's pretend that we all took a sample together and we got a p-hat of 40% or 0.4. So my p-hat is 0.4. So this is called our point estimate. Okay, we're essentially using this p-hat to try and estimate the true proportion of red beads in the bag. So the population is all the beads in the bag. The sample was the 20 beads that I sampled. The parameter is the true proportion of red beads in the bag. And that's something that we don't know, which is why we have the p-hat, because we use the p-hat, the point estimate, to try and estimate the parameter. And the statistic is still the p-hat, so 0.4. But then we said, okay, well, 0.4 probably isn't exactly the true proportion. That's just an estimate. Like, it's probably like 0.4, like plus and minus some value. So we said, let's convert this p-hat into an interval where we end up with, you know, a number here, comma, and a number here that says, well, we think the true parameter is somewhere in between this interval. So in order to do that, we needed to take our p-hat plus or minus some margin of error. And today we decided that we would just kind of guesstimate the margin of error. Like, for example, well, I think that 0.4 might be like 10% off the real proportion. And so we said, okay, well, what's 0.4 plus or minus 0.1? Well, that would give me a margin of error a confidence interval from 0.3 to 0.5. So my interval is 0.3 to 0.5. Oh, actually, so this goes to number 4. So what I'm saying is, okay, I think I might have had, you know, somewhere, my sample of 0.4, it was an estimate for the true parameter. I think my margin of error was about 10%. So I'm going to say, I think my true parameter then is in between 0.3 and 0.5. Okay, so again, your interval is just with open parentheses like this. And notice that your p-hat should be smack dab in the middle of that thing. And then we said, well, how confident do you feel that your interval captures the true proportion? And so again, today we were just kind of going with your gut. How confident do you feel? So some groups said maybe like 70% confident. And we'll talk about how we actually get those percentages later. But today we're just learning kind of what they're there for. So I'm 70% confident that this interval contains my true proportion. So this is a super, 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 super important interpretation. So we're going to practice interpreting the confidence interval. Okay, so we're going to say we are 70% confident that the interval from 0.3 to 0.5 captures, or you could say contains, the true proportion of red beads in the bag. So again, pause the video if I'm going too fast and you still need to write. So this is something that you can say every time. You're just going to literally switch out your numbers. So switch out the 70%, switch out the 0.3, switch out the 0.5 with whatever your numbers are. And of course the context too. But you should always have the same idea structure. So maybe this is something you need to memorize. Then we said, okay, well, one group got 0.27 to 0.33 as their interval. What was their point estimate? Well, we can find the point estimate by taking the average of those two numbers, because that's going to give us what is exactly in the middle. And the point estimate should be in the middle of our confidence interval. So the point estimate, we can do like this. And that gets us, our point estimate. So if you're imagining the confidence interval on a graph, this guy would be your point estimate, and then your margin of error would be sticking out to the left and right like this. where this would be one end of your confidence interval and this would be the other end of your confidence interval. So in this situation, our p hat is 0.3, and this is 0.33, 0.27. So my margin of error is this much. So margin of error is 0.03 in this case. Okay, so back to our confidence interval. One group claims that the true proportion of red beads is 0.35. Does your interval support or deny this claim? Okay, so remember, our interval was 0.3 to 0.5. And look, 0.35 is inside that interval. So I'm going to say yes. 0.35 is inside my interval. So therefore, I support this claim. If 0.35 was not in my interval, I would say I do not support this claim. It is not contained in my interval. And this is because confidence intervals contain all plausible values. So other important ideas are just what we already started right here, and the idea of finding the point estimate and the margin of error from your interval. So those are the things that you need to be able to do so far. So try to check your understanding and check your work on it with the key that's on Canvas. So I'm going to skip down to the second part of the notes so you can pause the video and then come back to it. Okay, so now we went to an applet called tinyurl.com/applet, and that's capital C, capital I. So you can do that. What I would do is pause the video, try and work through 1 through 6, and then unpause it, and you can check it with me. Okay, so on the applet, what you should have discovered was a couple of things. First of all, not all of your confidence intervals are going to capture the true proportion. Like that one at the top right now in red does not capture the true proportion. But notice I'm going to keep sampling until, see now look on the bottom left, it has the total. I've taken 100 total confidence intervals now, and about 97% of them capture the true proportion. And I'm at a confidence level of 95%, so I'm going to keep sampling. Let's see how that changes. And guess what? If I kept sampling and kept sampling, eventually I would contain the true proportion exactly within 95%.